Okay, so Manami, all these lectures will be recorded and uploaded on the website. So you can also go through the arithmetic progression lectures from the website to cover that. And I'm also gonna try to keep extra classes with you for this. Okay. So we're done
Alright,
with
miss.
arithmetic progression. Today we're gonna start with the second part, which is geometric progression. Okay. All right. Let's start with that. What do you guys understand from geometric progression? Geometric series. What do you think it's going to be about? Aisha, especially you, I'm asking you. So
Yes.
in arithmetic series, we had a constant common difference, yes?
Mm.
Okay, all right. So geometric progression is something like this. So Monami, we have something known as A, which is the first term of the series. Then we have D, which is the common difference. In geometric progression, it's called the common ratio, which is calculated by R2 upon R1. R1. So for example, we have a series 1, 2, 4, 8, 16, 32. So we have a difference of 2 over here, D2 over D1. Yes, we have a difference of 1 over here. Then we have a difference of 2 over here. Yeah. Then a difference of 4. Then 8. Then we have a difference of 16. Is the difference between the terms common? Is it the same difference? No, right? But we can obviously see that there is some kind of a relationship, yeah? Because it's a geometric progression. So how do we calculate this difference? If we want to calculate this difference, we do R, which is known as, we don't write D, we write R. So R is equal to D2 upon D1. Okay? So this would be equal to, what is D2? The difference between the D3 and D2. Okay, so this is going to be D3 minus D2 upon D2 minus D1. Yes? Are you guys understanding?
Yes.
Actually, no. Let's just do it a much simpler way. You can calculate R simply by dividing term 2 upon term 1 or any preceding term upon the previous term. So for example, over here I can do, what is my T2? So Manami, we have T1 over here, we have T2 over here. This is T3, this is T4, T5 and T6. By T, I mean term, okay? So we can do T2 upon T1. T2 is 2 upon 1. Yes?
Understood, miss.
Yes. So this is the common difference. Whenever you will multiply, so this is your R. So my R's value is 2. All right. Now, like in arithmetic progression, we have a term formula. In this progression, we also have a term formula and a sum formula. But what I need you to notice, let's just write the formulas first, okay? So we have, this can also be T2 over T1. This can be any term and the preceding term. This can also be T3 upon T2. This can also be T4 upon T3, okay? So you understand the next term and the previous term, okay? All right. So we have the term formula. Why do we use the term formula? We use it to calculate the next term. So what is the term formula? Over here we have Tn is equal to A to the R to the power n minus 1. My n is the term I want to find out. R is the common ratio. And A is the first term. So for example, I want to find T7 in this series, which we were working with previously. Okay, so how will I find that? I know my A is 1, my R is 2. So the common ratio will stay the same. Can you see? If I want to calculate the common ratio, I can use multiple methods. So I can either do T2 over T1, which will be 2 over 1, or it can also be T3 over T2. So 4 over 2 is also 2. Do you see the common ratio will always stay the same? I can also do, for example, T6 over T5. Yes? If I want to do T6 over T5, what will it be? 32 over 16. This is 1, this is 2, so the common ratio will stay 2. Alright? So this is the information we needed. And we need n. What is the n we need to find? It's the next term. So n is 7. Okay? So we will do, let's plug in the formula now. T7 is equal to A, which is 1, R 7 minus 1, as it's n minus 1. So we will do T7 is equal to 2 to the power 6. Yes? Which will give me 64. Are you guys clear?
Yes, miss.
Yes.
Okay. Now I want you both to try and calculate the T10th of the same series. I'm on the 10th term, okay? Everything is in front of you. You just have to calculate it.
Will it be 512?
Okay, we will discuss it when both of you are done, okay? Aisha, you done? Yes? Okay, so we have T10 is equal to A R n minus 1. A is 1, R is 2, and I have 10 minus 1, which is 9. So it's going to be 2 to the power 9, which is going to give you 512. Correct. Did you guys understand this? Is it easy?
Yes.
Okay. All right. Now there's a pattern that geometric progression follows. Now, if you know this pattern, the questions will be much more simpler for you to answer. So there can be 4 types of series. GPs. What is GP? GP is geometric progression, okay? Let's look at the first type. So the first type is what we did, where we have 1, 2, 4, 8, 16, and 32. So as all of the terms are positive, the R will also be positive, okay? So I'm just going to write here, all terms positive, R will be positive. And if R is positive, then the number will keep on increasing, okay? Terms will keep increasing. All right? Because R is positive, so the common ratio is positive, the term is also positive. 2 conditions are being fulfilled. So the numbers will keep on increasing. Okay, this is condition, let's make it condition A and condition B. Second type of series is, I have 1, minus 3, 9, minus 27, and 81. So over here, My A is positive. My A is positive. So my signs will, and R is negative. Okay. So signs will alternate. Okay, now over here, A is also positive, R is negative. So if A is positive and R is negative, signs will alternate. In the first one, all terms were positive. So, and R was also positive. So A is also positive over here. I can also say that A is positive, R is also positive. So all terms will keep on increasing, okay? Third, I have minus 4, 16, 60, minus 64, 250, minus 1024. So in this series, my A is negative. A is the first term. And can you calculate R for me? What will be R in this series?
Negative.
Negative. What is the value?
-4.
-4.
Yes, negative 4. So R is negative. So when A is negative and R is also negative, then what happens? Then also signs alternate. Okay. Let's look at this last type of the series. We have -5, -25, -125, -625. Can you tell me R for this? A I know is negative. What is R?
+5.
Yes, it's a positive 5. So it's a positive number. So can we conclude if A is negative and R is positive, all terms are negative. Yes? You understand? So let's look at all 4 types now. So when my A was positive and R is also positive, all my terms were positive. This is the first type. Both are positive, all my terms will be positive. The second type is when A is positive but R is negative. So signs will alternate. If A is negative and R is also negative, signs will again alternate. Okay? Alright. What you can conclude from this is, as long as R is negative, signs will alternate. Yeah? Yes? Do I make sense?
Yes, miss.
In the last one, my R is positive, but A is negative. So all were negative. Okay? So there are 4 staple rules we should know. When both are positive, all terms will be positive. When R is negative, terms will alternate. And when A is negative and R is positive, all terms will be negative. Okay? This is not something you need to learn, but if you know this, your questions will become much more easier. All right? Okay. Now there is one other thing I need you to know for this chapter. I need you to know indices. Do you know the rules of indices? I'm sure you've studied it before. So there are some rules of indices that you should know. First, if there is AM into AN, what will be my answer?
A to the power m plus n.
Yes, as long as the bases are same and they're being multiplied, the powers get added. Secondly, if it's AM divided by an. What will be the answer?
A to the power m minus n.
Yes. When the bases are the same and they've been divided, the powers get subtracted. Aisha, are you clear with this?
Yes, miss.
Okay. All right. So I have am into an. No, wait. It's not an. Wait. It's an into bm. What will happen here? So whenever the bases are different but the powers are same, you can multiply the bases and take the power common. Okay. So for example, I have 2a into, or I have 2 to the power x into 3 to the power x. This can be written as 6 to the power x. All right. Let's look at the fourth one. If I again have am divided by bm, again, you can divide them and take the power common. Because the bases were different, but the powers were the same. Now, I have a to the power minus m. How can I write this? Whatever term has a negative power, it can be written as a upon a to the power m, and the power becomes positive. So for example, you have 2 to the power minus 1, it can be written as half, and other way around as well. So half can also be written as 2 to the power minus 1. Let's do this one. So according to the previous rule, I told you that you can just reciprocate the powers, yes? You can just reciprocate it to make the power positive. So over here, I have a upon b to the power minus m. So to make this positive, I can write, I just reciprocate it and the power becomes positive. Let's look at another law. This is the last one where I have a, b. So do you know if there is nothing written in the root sign, it means a square root. Yeah, there is a square written, but we don't write it. But when it's cube root, we write the cube. Yeah. So if I want to convert, for example, 2 square root in dice form. So how can I write it? 2, whatever the power of 2 is, comes over here in the numerator. So the power of 2 is 1. And this 2 comes in the denominator. So 2 to the power half. Similarly, if I have cube root of 2, again the power of 2 is 1 and the power of the root sign is 3. So that comes in the denominator. Similarly over here, a is my base, the power of a is 1 and the power of the root sign is b. So b comes in the denominator. Are you guys clear till here?
Yes, miss.
Yes.
Yes? Okay. Aisha, you are also clear? I
Yes.
feel like let's do some questions for indices first and then move on with the sum formula. Okay, so I want you guys to solve these questions. solve these, okay? And let me know once you're done with all three. Are you guys done?
Yes, miss.
All right.
Yes.
So this would be 2m plus n. This would be 2m minus n. What would this be?
2m/2.
Yes. Aisha, did you do the same?
Yes.
2m by 2. Yeah, because the power of the root is 2, so that comes in the denominator, and the power of 2 is m. All right, perfect. Good job. Okay, let's look at the sum formula for the series. We looked at the term formula, which is AR to the power n minus 1. Okay, this was the term formula. Let's look at the sum formula now. Okay, so we have two sum formulas. The first sum formula is Sn, sum of n, A bracket Rn minus 1 upon R minus 1. And we have another sum formula, A 1 minus R to the power n upon 1 minus R. Now, there are some conditions where we use either of these formulas. So if the number is greater than 1, then we use this one. So if R is minus 1, greater than minus 1, and lesser than 1. That means between minus 1 and 1, irrespective of the sign. we use this formula, the first one. So what does this irrespective of the sign mean? It means, for example, my R is minus 0.5. I will not look at the sign. I will just see the number. Is 0.5 between 1 and minus 1? Yes?
Yes.
Yes. So I will use the first formula. Okay. I will not look at the sign. Okay. Now, when do we use the second formula? We use it if R is smaller than 1. Again, irrespective of the sign. So this is basically used when R is greater than minus 1 and lesser than 1. This one is used if R is, basically what you need to see is this part. How will you understand by this part? The denominator can never be negative, okay? So when will I use this formula? If R is greater than 1, I will use this formula, okay? If R is lesser than 1, I will use this formula, okay? Because the denominator can never be negative. So you can also write, to make it less complicated for you, just write if R is greater than 1, okay? And if R is smaller than 1, you use this one. You guys clear? Now you will not look at the sign, okay? Sign doesn't matter. So for example, my R is minus 1.5. Which formula will I use?
The second?
The second?
Yes.
If I use the second formula, it will be 1 minus 1.5 with the denominator, which will lead to?
0.5.
Yes.
0.5.
We can't use this one. We have to use this one. The first one. Because whenever R is greater than 1, we use this one. When it's less than 1, only then we use the second formula. Okay? So for example, R is minus 1.5 or 1.5. In both cases, the sign doesn't matter. We will use the first formula because it's going to be 1.5 minus 1. Okay? We use the second formula when we have, for example, R as 0.5 or 0.75 or 0.25 when it's less than 1. Okay? Then it's going to be 1 minus 0.5 or 0.25. All right? Are you guys clear?
Yes, miss.
Yes, miss.
Okay. Are you sure you're clear? You can ask me if you're not. Okay, I'll assume you both are clear. Alright, so these are our formulas for sum. Okay. Now, what you need to know is, so for example, I have, this is my term formula, yes? TNARN minus 1. So when n is 1, what will be my term? It's going to be a to the power 1 minus 1, yes? So it's going to be a, which we already know, term 1 is a. Yes? We call the first term a, right? Let's look at when n is 2. So I'll put in a, r, and 2 minus 1. Yeah? So 2 minus 1 will give me ar, power 1. When I put in n as 3, it's going to give me ar 3 minus 1, which is going to give me ar squared. N is 4 is going to give me ar 4 minus 1, which will give me ar cubed. Do you see a relationship? The power of r is in relative to the term. So if the term is 1, the power of r will be 0. The power of r will always be 1 less than the term. Okay? Power of R will always be 1 less than the term. So if we look at the first term, the power of R over here, can I write it as 0? R is 0. Then you look at the second term. What is the power of R over here? It's 1 less than the term. So we have second term. The term is second, power of R is 1. The term is third, power of R is 2. Term is fourth, power of R is 3. Do you guys understand?
Yes, miss.
Very small relationships you should know, alright? Okay, let's start with a few questions now. So Monami, this is your first class. I'm sorry I forgot to introduce myself. So I'm Ms. Anushya. I'll be teaching you maths. So we have 2 classes in a week. I'm sure you know have the timetable. Yeah?
Yes, miss.
Yeah. So we have a class on Mondays and Fridays. And we have lectures in class and we do some practice questions. Then I give some practice questions as homework. And the starting of each class, like the starting 15 minutes, we discuss all the questions in the homework that you guys weren't able to do. Okay? Then we move on to the next part of the lesson. Okay?
All right.
All right. You're added in the WhatsApp group.
Yes, miss. I think I got added.
Okay. So I'm going to send some questions on the WhatsApp group and I'm going to write them over here so you guys can start solving them.
Okay.
Okay. Yes, you're on the group. Okay. So in this question, what you have to do is, you will just tell me which of these are geometric progressions. How do you know something is a geometric progression? It will have a common ratio, okay? So you will check at least 3 ratios of 3 terms individually and see if they're the same, okay? I will tell you which questions to do. I'm writing them down over here. You guys will do question 1, part B, D, F, and H, 4 parts, all right? And also L, okay? We're doing 5 parts right now. Once you're done with B and D, let me know, all right? Are you guys clear with how to do this question?
Miss, I'm not. What did they ask by
Okay,
how do we decide?
we'll do one part over here. So
Okay.
I'm doing question 1A. They have given me 2 plus 6 plus 18. So these are terms, okay? Plus 18.
Is plus like the comma? That's
Plus
it.
means, no. Plus means it's a positive term.
Oh, okay.
Okay, these are separate terms. Plus 54, plus 162, plus 486. So they are saying check if it's a geometric progression. So when we started geometric progression, I told you that they have a common ratio. And how do we calculate the common ratio? We have to calculate we divide 2 terms, 2 preceding terms, yeah? 2 consecutive terms we have to divide. So I will take it out for like 3 terms. So first I'm going to take T2 and T1. So R for T2 divided by T1. 6 by 2 is equal to 3, okay? Now I got 3 for this. Now if I get 3 for something else, and like if I check for every term, I will have to check for every term. So now I'll have to divide all of them and see if it's a constant ratio. So now I will divide T3 by T2. 18 by 6. Is 18 by 6 3?
Yes.
Let's divide T4 by T3. 54 by 18. Is it 3?
Yes.
Yes. Then we will do the last 2 terms. So I have T5 by T4 now, which is 162 by 54, which is going to be again 3. then the last one. So it's going to be T6 by T5. Are you understanding what I'm doing?
Yes, miss.
I'm just seeing if the
Yes.
ratio is constant. I have to check if at any place it comes out to be not constant, then this cannot be a geometric progression. So for every term, the ratio was the same. So this means I just write the common ratio is the same. The common ratio is constant. Hence, it's a geometric progression. GP. GP means geometric progression. All right, you guys understand now?
Yes, miss.
Okay. So you can start with these parts. All right. Okay, how many questions are you guys done with? Aisha, how many questions are you done with?
3.
Okay, and Monami, you?
I'm in the last one.
Okay, great. So is B a geometric progression?
Yes.
Yes.
Yes. What's the ratio?
-2.
Yes, correct. What about D? Is D a geometric progression?
No,
No.
No.
Correct. Yes. What about F?
it's also not a
Yes.
geometric.
Yes. Okay. Monami, I'm sending questions. You can start with those.
Miss, for L, is it going to be a geometric progression with the common difference of 1?
1.
Yes.
Okay, let's see. Aisha, you done?
Yes, miss.
Okay. Was H a geometric progression?
F.
H.
Yes. H is
Yes.
geometric progression.
What's the ratio?
1/2.
Okay. So you were saying for H it's 0.5, 1/2?
Yes.
Yeah. And what about L?
L is geometric progression.
Yes. And what's the ratio?
The ratio is A.
A. Yes, it's A. Monami, I'm going to do it over here for you. 1 plus A plus A squared plus A cubed plus A4 plus A5. So when you divide A with 1, you get A, right? You don't get 1. Even if I divide a squared with a, what would I get? A, right? So the common ratio is a. Alright?
Right, miss.
Okay. I sent you guys another picture on the group. I'm going to send a PDF as well right now. Just do from this picture. I'm going to write the question that you have to do. So you will be doing, in this you will have to find the term. So for example, in part A, I have to find the 10th term, okay? So for this, you will find A, then you will find R. So I will do A part. So I have 2 plus 4 plus A. And I have to find the 10th term, yeah? First job is to tell what is A. A is 2, right? Now I have to find R. R would be 4 upon 2, which is 2. So now I will use my term formula to find out the 10th term. So it's A R n minus 1, which is going to be 2, 2, 10 minus 1, 2 into 2 power 9. Yes? So you'll just solve this 2 to the power 9 into 2, which will give you 1024. Understand? So for each of the questions, you will have to use this formula and find out. Yeah? So you will be doing question 2, part F, G, H, I, J, K, and L. Okay? We will be doing this today. Are you both clear with how to do this question?
Yes, miss.
Yes.
Okay. Okay. Manami, do you like maths?
Yes, miss, it's fun.
Yeah. Yes. What are your other subjects?
I have physics, maths, and computer science.
All right. Okay. Both Aisha and you are on the same pace. You're at the same level also. So, you know, you can easily grasp in class. Both of you are on the same mental level also. You both are very good at maths. I can see, okay? So it's going to be fun in class. Okay, how many questions are you guys done with? Aisha, how many questions are you done
Yes.
with?
I'm on I.
Yes? How many questions are you done with, Aisha?
4. 4 minutes.
You're on which one? F? G? Which
I.
one?
I'm on I.
Okay. All right. And Monami, you?
I'm on K.
Okay. So I sent you both a document on WhatsApp. So if you scroll down the document, you can see the answers. Okay. So keep checking your answers as well. This is question 2. Okay. Scroll down, you can see the answers on page 69. Aisha, did you see it? Okay, and I'm also going to tell you some homework questions from this document, okay? And the rest we will do in class in the next class on Friday. So right now we're done with question 2. We did question 1 as well. I just want you to do question 2, A to E, and question 3 as homework, all right? And check it at the back as well. Okay?
Alright.
Okay.
For question 2, are your answers correct? So for 2F, I have, just check, I'm telling you. 2F, you have 2 upon 625. Yes? Can you guys tell me your answers, please?
Miss, I got all of them correct.
You got all of them correct. That's